Okay, so this is the last circuit video that we're going to be doing, and this circuit video is about complex combination circuits, so it's geared towards our K-Level 6 students. So before we begin, we always like to look at the numbers that we're going to be working with, and in this case we have, again, voltage is equal to current times resistance, that's Ohm's law, and then we also have power is equal to voltage times current. So V is for voltage in volts, I is for current in amps or coulombs per second, R is for resistance, and that's in ohms, which also is the Greek letter omega, and then P is equal to power, which is in watts. Okay, so that's not going to change. The only thing that's going to change instead of having circuits where the components are completely in branches and separate branches, we would call this a parallel circuit, or where we have circuit components that are all in a row, we will call this a series circuit. Now we have circuits where there are elements of both. And so our problem-solving approach, I call it smooshing. We're going to smoosh some of our components together. In this, if I was going to solve this circuit, I would try to combine these two resistors so that after smooshing, I would have a circuit that looked something like this, and this would be the equivalent of R2 plus 1, and this would be R3. For this circuit, I have two circuit components that are in series on a parallel branch with another circuit. So for this one, I would smoosh 2 and 3 so that my new circuit would look like this, R1 and R2 plus 3. Now, of course, if you have this kind of circuit, you can't actually squish the two together and add their resistances, okay? But we can do it with numbers theoretically. So what I'm going to do is show you how to do the calculations for this circuit. So there are a couple of ways that you can do it, and different students find it easier to do it in different ways. So I'm going to draw a circuit, and you can do this anytime that you like. You are capable of solving and creating your own problems, and if you want to make sure that you've done it properly, you are more than welcome to come and visit with one of your teachers. Okay, so in my circuit, I'm going to say that my total voltage is, let's say, 9 volts. Resistor 1 has a resistance of 10 ohms. Resistor 2 has a resistance of 20 ohms. And resistor 3 is going to have a resistance of 30 ohms. Okay, so the first way that we can look at this is we can look at it as if we were going to actually make a separate circuit. So to do that, I would draw two different tables. Okay, so when I combine these, okay, I'm going to smoosh these two so that it will look kind of like we did up here. So it will look like a series circuit. And so in the act of smooshing those, this would be R1, which is still 10 ohms, and this would be R2 plus 3. And I would make my little table. So I would say R1, R2 plus 3, and then total. V, I, R. Okay? So that's one part of it. But in order to smoosh it, we also have to recognize that we have a part of our circuit that looks like this, and that's R2 and R3. So this is going to have its own table as well. So we're going to have R2 and have R3, and we'll have R2 plus 3, which will be our total. And it's going to have V, I, and R as well. So the key thing to remember here is that whatever goes in this row also goes in this row. Those rows are essentially the same thing. And it's also important to remember that in this table where we have our parallel components, we're going to use parallel circuit rules. In this table where we have our series components, we're going to use only series rules. So that's why I find it helpful to kind of color code things. Okay, so as we always do in physics, we're going to go through and we're going to add our given information. So I know my battery has a voltage of 9 volts. That's going to go under total. And I also know that resistor 1 has a resistance of 10 ohms. Okay, R2 and R3 are in parallel. So I'm going to put their resistances over here in my parallel table. So R2 has a resistance of 20 ohms. R3 has a resistance of 30 ohms. Okay? Now, from here, it looks like we really don't have very much of a start. But if I could figure out what the equivalent resistance of resistors 2 and 3 is, then I could figure out my total resistance of this circuit and then use that to figure out my total current. So let's go ahead and do that. So if you recall, the formula for equivalent resistance in a parallel circuit is 1 over RT is equal to 1 over R1, in this case it's R2, plus 1 over R3. Okay, so 1 over RT is going to equal 1 over 20 plus 1 over 30. Okay, and if you want to, you can do lowest common denominator here. It wouldn't be very difficult, but I'm going to show you how to just plug it into the calculator if you want to. Okay, so it's 1 divided by 20 plus 1 divided by 30. The answer that you get there is 1 over RT. It's not RT yet. You can invert it. So you can either do 1 divided by answer, or you can just push this button here, x to the negative 1, and it'll show you that the equivalent resistance there is going to be 12 ohms, which is nice and pretty. Okay, so now I'm going to take my 12 ohms, and I'm going to put it over here where it's going to pretend to be 2 resistors squished together. Okay, now from here, since this is a series circuit, current is what's constant, everything else adds together. So 10 plus 12 is 22 ohms for my total resistance. And then to find the current, V is equal to I times R. So if I want to solve for current, I divide both sides by R. So V divided by R here. So it's going to be 9 divided by 22, which gives us 0.409. So I'm going to round it to 0.41. So when you have any kind of rounding, it's going to affect your results a little bit. But if you're close, you'll be fine. And our test, remember, is multiple choice. So you'll be able to pick the one that's closest. If you get some that are off by 5, you might want to check. Okay? All right, so again, in series, we know that current is constant. So I'm going to put 0.41 all the way up. And then in order to find our voltage, remember V is equal to IR. This time we're solving for voltage. We just have to multiply current by resistance. Okay, so 0.41 times 10 is 4.1 amps. And then 0.41 times 12 is 4.92 amps. And if we add those together, we can probably leave off the 0.02, but 4.1 plus 4.9 gives us 9 volts. Okay, and I know it was 9.92, but it would be 9.02, which is fine. It's close enough. Okay, so then we can take all our information from this row and put it back over here to kind of separate out the voltage and current for each component in parallel. So we had I'm going to go ahead and say 4.9. I'm going to cross that 2 out. 4.9 volts, and our current was 0.41. Okay, so as you recall, the current in parallel is no longer constant. In fact, the voltage is constant. So I can put 4.9 and 4.9 here. That's because as the current travels through the circuit, 4.9 volts will be lost on this branch, and 4.9 volts will be lost on this branch too. So now we're going to use Ohm's law to solve for resistance. So V is equal to IR. We're solving for resistance. We're going to divide both sides by current. Okay? Or, sorry, we're solving for current again. That's down here. My bad. Okay, so we're solving for current. So we're going to divide voltage by resistance. that isn't confusing enough for you. So 4.9 divided by 20 gives us it says 245. I'm going to put 25 here. And then 4.9 divided by 30 is 0.16. So if I add 0.25 plus 0.16, I get 0.41, which is what we got in this box here. So you can see like all our checks work out, okay? Our two voltages in series added to our total voltage, our two currents in parallel added to our total current that we found. So this circuit has been solved. So then if the question were to ask you, okay, what is the current through R1? You could find R1, find the current, it's 0.41. What's the current through R3? You could find R3, find the current, it's 0.16. It becomes very simple to find your information once you've gone through that table. There is another way where you create just one table, and I'll make a separate video to go over that one. So if you have any questions ever, just ask your teacher, and we'll be more than happy to help you. Thanks.